Hi, this is Paul with a tutorial on OctaneRender for Modo, looking at how assemblies can be used in the schematic for Octane overrides. So I'll just add a sphere to the scene here and go into the Octane tab and create a material group for the sphere. So you can see in the shading tree we've got that material group, and we add an Octane override to it. So you can see there is the sphere Octane override, which is down here. So we can take one or more nodes that are on a schematic and put those into an assembly, and we can then use that to share a common set of nodes between different scenes. So to do that, we first create an assembly, and we'll call it, say we're going to put a checks node in the assembly, we call it checks. So if you need to go into that assembly first. All looks good. We'll go back to our workspace and we will add, you can see the assembly there, we will add a checks, which we've done. So when you add a checks, there's actually three nodes there. There's the checks, there's the transform, and there's the projection. So if we right click on those, we can move them into the assembly. So the effect of that is we have the Octane override, we have our material, and then we have the assembly, the checks assembly. So if we go into that checks assembly, you can see that it's got the checks node there. So we can plug the output of the checks into the assembly output, and say for example we want the input of this assembly to be the transform, then we can delete that transform and add a new channel. We'll call it transform, and it must be float. That's the only criteria here, and then that transform can fit into that checks node there. So while you're doing this inside the assembly, there's no checking that what you're plugging into an Octane node is legal. So when you go and render this, if you've plugged something in that shouldn't be plugged in together, you'll get an error message. If we go back to the workspace, so you can see our checks assembly has now got the transform as an input, and we have an output. So we can put the output to the, I'll actually set that rendering so you can see it. If we set the output into diffuse, then we can add a transform there. So we'll go a new transform value and plug that in. So then when we set the scale to say, so you can see this transform value here is going through the assembly into the material, and you can see that as I set values for that transform, it updates live on the screen there. So you can now take this assembly, you could save it as a preset, and you could use it elsewhere. So for something simple like checks, there's probably not a huge amount of benefit, but for really complex subgraphs, there could be a big benefit. And to give you an example of that, there is the Quixel shader. So this is was my attempt to reproduce that in the plugin, and you can see that I've got the Octane override here for the box, which is there. You can see I've got a box in the scene, and then there are at the moment 6 inputs, and you can see that, for example, the diffuse texture, I've got a texture map there, and if we look inside this subassembly, it is huge. So if we click in there, you can see it's really quite a complex set of nodes that are hidden from the user. So the there's a number of materials. you can see the output is here. There's the output, and more interestingly is the inputs. So you can see that I have manually added the 6 texture map inputs to that assembly, so then they appear on this list here. So that should, with a bit of imagination and ingenuity, you can make up some pretty complex structures there. It's effectively like the subnode graph in Octane standalone, and it works really nicely. Hopefully that is helpful to someone. Thanks for listening. Bye.